Okay, let's get started. So we're going to investigate the rhombus and square today, and that's going to tie off one side of this quadrilateral section that we're doing. Then we're going to move off to another side and deal with trapezoids and kites. So we're finishing this side up. So rhombus is something that's less remembered. It's very similar to a square as that it has four congruent sides. Start there. Four congruent sides. And the usual shape we think of that has four congruent sides would be a square, but this is not a square. So how come this is not a square? Yeah, no right angles. So we're not quite there. We just have a square has four right angles like a rectangle, and it has four congruent sides like a rhombus. So this is partially there, almost there. Okay. So we have, but like everything else we did with rectangles, a quadrilateral is a rhombus, then it is also a parallelogram. So we get all the properties of parallelograms. That seems to be the encompassing property set. Okay. Meaning we still have parallel sides. Two sets of parallel sides, right? We do have the segments, not segments, the diagonals are bisected by one another. That is also true. So these are just the properties of parallelogram. So if it is a rhombus, it is automatically a parallelogram. Don't forget that H in rhombus, by the way. All right. And what is unique to the rhombus? Look at those. So if it's a rhombus, then the diagonals what? They're not congruent. Sorry, we still have one that's long, one that's short, but they are perpendicular. So in other words, they make a right angle. Okay, so right there. So we have right angles. The symbol for perpendicular, you might recall, is upside down uppercase T. So perpendicular. There we go. Okay. And what about the diagonals? Also, let's go orange. Diagonals, again, it's always about the diagonals. There's always something special with those. Each diagonal bisects a pair of opposite angles. We got four sets of opposite angles here. So this diagonal right here bisects angle B. So if I label this 1 and this 2, that would mean that angle 1 is congruent to angle 2. And that happens all the way around. And through all our triangle congruencies, we could actually prove a lot of these are congruent to each other. So not only are these two equal, they're going to be congruent to others that are in the same rhombus. Let's call this one 5 and 6. And let's go, what am I at? Orange, yeah. 7 and 8. There we go. So since we have parallel lines here, if we extended AC as a transversal, we could show that angle 4 and angle 7 are alternate interior angles and they're congruent, and 3 and 8 are congruent, and 2 and 5 and 1 and 6, and show that all these 4 different triangles are congruent as well. All right, so let's practice using a few of these. So we have, what is the measure of VZW? A little bigger. VZW. So there we go. VZW right here. After we just got saying this is a rhombus, so what is the measure of this angle here when they bisect or when they cross? These are all 90-degree angles. So if one of them is 90, they're all 90. So it's a 90-degree angle, nothing more than that. So it's kind of a simple question when you know it's a rhombus, right? VW. Okay. So since it's a rhombus, these are congruent to each other, right? All sides, not just those two, but all sides of a rhombus are congruent, and they have perpendicular diagonals. So here, if I want to find VW, I know it's congruent to any other side, including WX. So we'll have VW is going to be equal to WX because it's a rhombus. So VW is 6m minus 12 and 4m plus 4. Do a little solving, subtract 4m on both sides. 6 minus 4 will be 2m. Add 12 to both sides. 4 plus 12 is 16. So m is 8. Good. And are we done? Is our answer? No. Yeah, we need to know what VW equals. We have what m equals. So a little bit more. I'll put it right here. VW is 6m minus 12. So that's 6 times 8 minus 12. 48 minus 12 is 36. There we go. We know this side is 36. All right. And then the very next question asks, what is the other side? What is WX? Yeah, we just already labeled these are congruent, right? So if we found out that VW is 36, this is automatically 36 through the properties of a rhombus. We don't really need to plug it back in. If you weren't sure and you're trying to be extra careful, which is always a good thing, you could do, well, WX is 4m plus 4. Plug in 8, so we got 32 plus 4. And by no surprise, what does it equal? 36. So that's how you get an A on quizzes. Even though you don't need to do the work, you do it anyway and check. And if it matches, you know you have it 100% correct before you turn it in, right? That's one of those characteristics of people that do really well on tests. They'll come up afterward and say, I know I got these 8 correct because I checked them all, but this one I wasn't sure because you couldn't do a check. But they already know their grade. They're not hoping or wondering, I wonder if I got it. I wonder if I got that one right. I wasn't sure. They've already checked everything. They know the grade. Okay. So let's move on, do a little bit with the expressions. So we have x equals, let's see here, label everything. Let's just be careful about it. Use the colors, use all the good stuff, not make any mistakes. Okay, AM is 4x, right there. Have AK is 5x minus 3. Okay. Then we have DL which is 10. No, that's 4x. That's 5x. Was it minus 3? And right here, that's 10. There we go. All right. So what do we know? Well, it says it's a rhombus, so I know it's a right angle. I can put that in there. I know it's a rhombus, so these are all congruent. So I can put those on there. Sometimes they'll help just to have it written there. Put them in there. All right. And I want to know what x equals. Now, it doesn't say anything about these diagonals. A rhombus does not tell us diagonals bisect each other, but back up here, we did say that a rhombus is also a parallelogram. So you do get all those properties from parallelograms, the ones you just took your quiz off. So because of that, we do know these two are congruent. Not because it's a rhombus, but because it's a parallelogram. So it's basically a problem that you guys have been doing for several days now. So if we know 4x is going to be equal to the 5x minus 3, we can go and solve this and have 3 equals x, which we're trying to find. Okay. And next we have AL. Let's go green. So if I want to find just AL, right here, from here to here, what will that equal and why? Now, that'll be 5, right? Because, once again, because it's a parallelogram as well, these two sides are bisected, they're equal. So if the whole whole diagonal is 10, that means each one of those has to be 5. Very good. What about the measure of KAL? Yeah, 90, just as before. So we got measure of the diagonals of a rhombus are 90 degrees. By the way, if there's a 90-degree symbol here, that means all 4 of these are 90 degrees. We don't have to put actual 4 of them there. Just one of them will suffice. It's assumed all the others are true. And lastly, DM. So we want to find what does DM equal? Well, we know this side right here is 5. What does this side equal to? It's 4x, but what does x equal? 3, so this side is 12, right? So we have a side of 12 and a side of 5, and it's a 90-degree angle for the triangle. So therefore, we have this, right? 5, 12, 90-degree angle. How would you find out what DM equals? Pythagorean theorem, yeah. A squared plus B squared is C squared. And I can actually write DM squared if I wanted to. And so 25 plus 144. And then take the square root of both sides. We'll have DM is equal to 13. There we go. So if this is 13, that means all of these are 13. And what must the 5x minus 3 equal, by the way, while we're at it? Everything else being true. Yeah, this is 5 and 5. Everything's 13. This is 12. It makes sense that this is 12 as well. And you could double check by plugging in 3 in here. 5 times 3 is 15. 15 minus 3 is 12. So you can see this is a complete rhombus with all the sides and all the diagonals all labeled. We get 4 congruent triangles there. Pretty cool. All right. So leave it on over. Let's talk about square. Not too much to talk about because really it's just a combination of everything else we've done already. So if we have a quadrilateral with 4 sides congruent, okay, and 4 angles congruent, that is a square. Oh, for what I'm trying to say. Congruent angles, or let's say right angles. Yeah, congruent sides and 4 right angles. There we go. So basically, this top one, what is this shape that has 4 congruent sides that we just talked about? Yeah, so we're talking about a rhombus here. And what is the shape that has 4 congruent right angles? Rectangle, yeah. So we're just taking the properties of a rhombus and a rectangle, and you put them together, boom, got a square. So we have PQRS, so all 4 are right angles, so angle P, angle Q, angle R, and angle S are right angles, and then all 4 segments are congruent. Doesn't matter which order you list these in. Just know that there's all 4 congruent. So PQ, QR, RS, and PS. There we go. So if you have a square, basically every single property we've talked about is true. You can't really go wrong if you're trying to choose the right one or wrong one and you're not quite sure, because every single one is true for a square. About the diagonals, about the sides, about the parallel, about the congruent, about the consecutive angles, everything. Absolute everything, which is kind of nice, but also makes it a little bit boring. Has no special features of its own. Okay. So, quick review. A parallelogram this symbol, parallelogram. What do we know about the opposite sides? Okay, the definition says that they are parallel. Like, that's why they call it a parallelogram. And then opposite sides are also congruent. Right, that was the first theorem we saw. The next theorem about parallelograms, that opposite angles are congruent. Next, we know consecutive angles are supplementary. Anybody catch the typo here? Connective. Consecutive. Or adjacent. Non-opposite. And diagonals are what? Yeah, diagonals are bisected. There we go. All right, now for a rectangle, has all the properties of parallelogram, all those properties, right? However, with these diagonals, they are congruent. So with rectangles, we get congruent diagonals. And all angles are right angles. All angles Angles are right/90 degrees. And keep it going. Rhombus that we just talked about has all the properties of parallelogram. All right. Something different out of rhombus. All four sides are congruent. For rhombus only, what's true about diagonals? These are the last two theorems on the front. Okay. They make 90 degrees, also known as perpendicular. Also, diagonals bisect each pair of opposite angles. Yeah, that's just those two theorems on the front. We got a rectangle. Remember, rectangle has the angles. That's why the word angle is in rectangle. Got the four congruent angles. Rhombus has the four congruent sides. So lastly, we have our square, which has all the properties of parallelogram. Seems to be a popular thing. But it also has all the properties of a rectangle. And it also has all the properties of a rhombus. Got it all. Those are all congruent. Okay. That will do it. Little note down here. I think number 5 is missing the figure. Let me draw that in for you. There we go. Where this is 70 here. This would be 1, angle 1, angle 2, angle 3, 4, and 5. Failed to get that figure in there.